Hi, good day, everyone. In the previous lecture, you should have an idea on what is a stationary time series and what is non-stationary time series. Okay, and the difference between the weakly stationary and strictly stationary. All right, so basically, you need to make sure that the mean is constant and then your covariance is not following the auto covariance does not depend on your time, right? It depends on your lag or the difference in time. Okay, so for today, we are only focusing on the model for stationary time series. Okay, and you can represent um, the process, general linear processes, it is said to be in this process if it can be expressed in this form. Okay, so the psi here, if you can see this, the psi actually is a sequence of constants. Okay, sequence of constant, and these actually satisfy, these are all finite. Okay, so less than infinite, right? So finite here. Okay, and the AT minus K here is actually a white noise process, lah. Okay, or you can say a pure random process. All right, with mean zero. Okay, and your variance uh, and constant variance. Okay, right? So if for time series, they are often modeled in this manner, the general linear process, because it would provide a more powerful and parsimonious way to represent a complex pattern, okay, as a linear combination of past values. So these are all based on your past values. So now, the AT here is a white noise. All right. Now, based on the first remark here, general linear process can be written in this manner. Okay, so let's say for your xt, right? If I'm going to write, expand this, psi null at plus psi 1 at minus 1 plus psi 2 at minus 2, and so on, right? Until psi k. This one would be AT minus K. Okay, so if I'm going to write it based on my backward shift, remember in the previous lesson we have gone through it. Okay, so I can write this in this form, psi 1. This is the backward operator, where what I'm doing right now, this thing. Okay, and then plus is psi 2 means this would be p square. Okay, and then a t, right? And then plus and so on lah. Okay, until this is minus k here, right? So here would be psi k b k a t. Okay, so this actually follows the backward operator, and since everything now is in the form of at, right? So this one here is actually like psi 0, psi null plus psi 1b plus psi 2b square plus psi k bk. Whole thing is at, right? Okay, and this thing would actually become your summation from k equal to 0 to this one. Okay, this is following your backshift operator here. Okay, this is what it's indicating. All right, and then so for the second condition, all your summation of your psi square, your coefficient, is necessary to be finite for this process to be stationary. Okay, the third remark would be all your ACF would be in this manner. Okay, we'll get into this later on in a bit. Right? And then your white noise process is strictly stationary. Okay, so you should know the difference already, between strictly stationary and weakly stationary. Okay, so at first sight, of course, initially this earlier part here would be a little bit would be complicated, but just now, as you notice, when I expand it, it's actually when you combine them, when you sum it up together, it would be in this form lah. Okay. All right. So this one all I'll get into this on what is the first order autoregressive in a bit here. Okay. All right. But just an idea based on your first lecture, first video, right? If you notice, this is based on your previous observation, your directly previous observation, and this is actually your AR1 model. Okay, because it's just following t minus 1, right? So your first order. Okay, now when we talk about parsimonious means the model, it adequately fits the historical data, okay, which means that you do not need unnecessary parameters. Okay, because simple models are easier to interpret, right? So we just want something, a model that only has the important parameters that is able to explain the data easily, okay, rather than including all the variables. Okay, so that is called a parsimonious model. Okay, so for today, we are going to get into the autoregressive process here. Okay, so by definition, as what you have learned earlier in the first video, the process is said to be an autoregressive process if if it satisfies the difference equation, okay, if it follows in this manner here. Okay, so this one is the phi, okay, and from your phi 1 to phi p are all constants, and then your AT is a white noise process. White noise process means again your mean is 0, and then you have constant variance. Okay, so this one is quite important, right? Now, for example, if I'm going to look into the AR1 model, stop sharing here. Okay. If I'm looking at the AR1 model, xt is equal to phi 1. Okay, if you notice in the previous video, it was all in Y, right? This time I just put it in X, lah, no difference. Okay, where your AT here is following a white noise. So AT, white noise. Okay, with the condition, this one I'll get into it in a bit. Okay, where all your phi is lesser than 1. I'll explain why it's 1. Okay, so now for us to determine the mean and the variance, so first, assuming that we are looking into a stationary time series, right, in this chapter. So first, we need to look at the mean. So E xt, okay. ET. Okay, so this one would become your mu x. Constant, right? So this would become mu x as well. All right, and then your mean of your white noise is 0. So when I move this to the other side, it would become mu x minus phi mu x equal to 0. In this case, if you notice, this would be equal to 0 as your phi is not equal to 1. Okay, all right. So, because of this condition lah. Okay, so now There would be certain cases if your regressive model does not give you these values. Okay, so you need to be careful lah, whether your mean is constant or not. Okay, and just be careful with that. If let's say your phi is not is equal to 1 means then it's going to be undefined lah. All right. So now if let's say I'm going to follow check on the variance. Okay, so now variance xt is equal to variance. Okay. Okay, so this one will become sigma x square, right? Okay, then here sigma square because I'm taking out the variance. So this one is square plus your white noise variance, which is constant. Now, when I group the variance of x together, so it would become 1 minus mm, x square equal to square. Okay, so when I to find what is my variance, it would be over 1 minus. Okay, so this is how you can determine how to find the mean and the variance in this case.